This week on Maker Update, taking your filament for a spin, a solderless USB port, adapting your e-bike to the EV grid, and getting your coffee under control. Hey, I'm Donald Bell, and this is Maker Update, our weekly show covering the latest DIY projects and tips to help keep you inspired. I hope you're doing well. We've got a great show for you. Let's get started with the project of the week. On his YouTube channel, Matt Denton shares how he made this remote-controlled filament spool. It's fun, it's silly, and you'd really have to be fairly invested in the 3D printing lifestyle to go to the trouble of creating your own RC filament spool. But don't judge a book by its cover. There's much more going on here than a design gimmick. 6 years ago, Matt shared a brilliant 5-part video series on how he made this Star Wars-inspired DO droid, and by Matt's own admission, the drive system on this filament robot is similar to what he used on the droid build. Essentially, this is a second pass at building a compact, two-wheeled, self-balancing robot drive, and this time the system is smaller, simpler, and easier to recreate. The electronics alone are dramatically simplified. Everything plugs into a DF Robot Romeo Mini ESP32 board, which is new for me and looks like a great option for dual motor robotics projects. There are 2 geared DC motors in this design, each with their own encoders for positional feedback. To take advantage of this feedback, especially with a design that would be prone to flipping over without some counterforce, Matt includes an Adafruit BNO85 IMU board, which connects to the Romeo Mini over a quick connection and delivers data on acceleration, direction, gravity, velocity, and more. With this data, in the included code, Matt can optimize how the robot takes off and slows down so that it can not only not tip over, but also stop on a dime. Let's not forget, this robot is perfectly round. To be able to push it around and not have it just roll off the table takes some real magic, coordinating position and feedback between the IMU and the encoder data from the motors. All of this is to say there's a ton to learn from this project, and Matt does a fantastic job covering everything in great detail. The 3D files, bill of materials, and the code are all available for free using the links in his video, which you can find from the link in this video. Now for some news. In partnership with DigiKey, Hackaday is running a new contest looking for green-powered projects. The contest runs until Friday, April 24th. To give you some direction, there are honorable mention categories for solar power, non-solar power, power efficiency, and extreme green power consumption. Also in the news, in the interest of benefiting from the EU's new Eco-Design for Sustainable Products Regulation, or ESPR, JAE Electronics has developed an easily replaceable USB-C connector that doesn't need to be soldered down. Instead, the design uses a pressure fit using screws to hold it in compression against the contacts of a circuit board. It may not be a perfect solution for every application, but it's interesting to see how regulations for sustainable design and right to repair can inspire innovation. More projects on his channel. Matt Gray shows how he adapted his electric bike to recharge from EV charging stations. Electric bikes are great, but often the infrastructure to charge them up while you're out doesn't exist. So why not piggyback on the charging stations for electric cars? Well, one big reason is that most EV charging stations use those big, unusual EV charging plugs, while most e-bikes are designed to be plugged in at home. So Matt wired up a converter housed in a 3D printed enclosure that fits on the back of his bike, and it seems to work well. It looks like a great idea for extending your e-bike range, so check out his video if you'd like to do something similar. While you're charging, maybe you can brew up a cup of coffee. By way of the James Hoffmann YouTube channel, which is all about coffee, I learned about this electric PID-controlled MokaBot prototype from Javier Tellols. The project essentially combines a classic MokaBot coffee brewer, an electric kettle, an internal temperature sensor, and an ESP32 board with an integrated touchscreen. Javier calls it the MokaBot. With the system, you can preheat the water and define a target brewing temperature, giving you a lot more control over a brewing process that's famously temperamental. If you're a coffee nerd, the James Hoffmann hands-on video is a great watch, and if you want to make one for yourself, Javier says he intends to open source the firmware, so stay tuned. Now for some tips and tools. On Instructables, Lewis from DIY Machines has a guide on designing a CNC type project without limit switches. With today's latest Trinamic stepper drivers, you can now perform homing functions just by monitoring the back EMF from the stepper motor. This sensing capability, called stall guard, is built into the Trinamic driver. It essentially can detect when the motor knocks into the limit of its travel. Lewis includes a video and a written guide along with example code you can use to play around with this feature on your own. And on Adam Savage's tested channel, Adam offers a recommendation and a demo of an inexpensive upgrade to the standard spray bottle. These are called continuous misters, and they seem to be a pretty ubiquitous beauty product, but they also happen to be a great way to store and apply isopropyl alcohol to model paint finishes for a deliberately weathered look. Check out Adam's video for a closer look and a demonstration of his painting technique. For this week's DigiKey Spotlight, check out this video from their DigiKey Product Discovery channel. You get a closer look at the boards and modules offered by DF Robot, made to give your project AI-powered multimodal perception. As our AI projects become more sophisticated, we can start combining the inputs they use to experience the world. So not only can a project interpret what you're saying and respond with its own voice, but it can also use computer vision to recognize that it's interacting with you and not someone else. This is all possible now, and for the most part using only offline local processing. Check out the video to learn more. And that does it for this week's show. Be sure to subscribe, leave a thumbs up, leave a comment if you can. A big thanks to DigiKey for making this show possible, and thank you for watching. I'll see you soon.